Hi everyone, this is Yaqian Chen from Chinese University of Hong Kong, Shenzhen. In this summer research program, we studied an Interestingness projection system under the guidance of Professor Sebastian Xie. Interest in scene projection is currently underexplored, but it is crucial for many practical applications, such as autonomous exploration and decision-making. For example, for autonomous exploration of the subterranean environments, we find it interesting to have a hole in the wall and changes future trajectory planning. For another example, in urban area, most of the autonomous driving system is also required to detect certain scenes based on users' preference. In general, our model is able to classify images given by robots into two classes, namely interesting and uninteresting classes based on only a few labeled training datasets given by users. Main difficulties for our project lay on four aspects. First, the number of training datasets is limited. For an unknown environment, users are only able to give a few training datasets to tell their preference. Second, detection objects are not determined. Previous detection systems, like autonomous driving detection systems, can only detect certain objects given by system builders in advance. Detection systems are not able to tell interestingness under every environment either. In this project, we expect our system to be robust enough and will work under any given environment. Last but not least, images belonging to interesting classes are very different from each other and sometimes will confuse the classifier. To this end, instead of detecting the objects that users may be interested in, we choose to classify robots' input images by comparing its distance between each training dataset to see if it is closer to the training images belong to the interesting class or uninteresting class. Our model mainly has three modules. First is the k-means algorithm to cluster the images into 64 groups to initialize the image data for later training process, then put the initialized position into the training model based on the VLAD network. Last, put the testing dataset and get the predicted classes. Simply use the voting algorithm. For clustering process, we build a convolutional neural network using digit-16 architecture neural network as the baseline encoding framework to encode the input raw data, and then use the k-means clustering algorithm to group image data. Then, the output of the clustering process is regarded as the initial training data, the encoded image data, and the cluster and the class centroids given by the clustering will be initial parameter for model in the next training process. In the training process, each image will be dragged from the training dataset as the query dataset, then randomly choose one image from the class which is same to the class of the query dataset, then choose three images from the other class as the support dataset. Encode both query and support dataset through VLAD network. The VLAD network used in the training process consists of two parts, the CNN encoder with digit-16 as the baseline framework and an extra VLAD layer. As the main component of a VLAD network, VLAD layer is inspired by the vector of the locally aggregated descriptor image representation, commonly used in image retrieval and image classification. We also choose to use the triplet loss function, which separates the pictures belonging to the different classes and move closer pictures belonging to the same class. In the testing process, we first use the similar network to encode the input test image and the training dataset. Through comparing the Euclidean distance between encoded dataset of the given training data and the input testing data, we will find the image which is closest to the input testing data. A simple voting algorithm will be used during the classification. The system will output the top 5 candidates which are closest to the testing image, comparing to the proportion of the negative image in the candidates. with the threshold. As a result, our model on average increased prediction accuracy by 30% compared to the state-of-the-art classification models like CNN, prototypical network, and machine learning. Thank you very much for